Hello everyone. In this video we are going to discuss the statistical quality control. Already in my last videos I have already discussed the quality and quality management. Right. I'm believing that everybody has seen that videos और फिर जहां हमने लास्ट टाइम छोड़ा था वहीं से उसको कंटिन्यू कर रहे हैं. तो let us start with the first technique, that is control charts. What we mean by control chart is it is used to control quality during the course of their actual manufacturing. The inputs are being controlled with the help of vendor selection, supplier quality assurance. The finished goods we are going to see in the next video with the help of acceptance sampling. But as far as processing of the raw material is concerned, processing of the finished good is concerned, so we are controlling the deviation, we are controlling the variation with the help of these control charts. So these charts are used to control the quality during the course of their actual manufacturing. In other words, we can say work in progress जब execute हो रहा है या raw material पर जब हम processes कर रहे हैं, so how we are going to check the quality of the work in progress? In that particular case, we are going to use the control charts. It is a graph with lines which indicate the tolerances. And tolerances का मतलब क्या है? These are the limits within which variation from the average quality is permitted. Average quality का मतलब है जो भी हम एक average decide करते हैं, because we have seen कि variation defects होना inherent है, inseparable है. Two products cannot have the exactly same quality, right? So there are few things that we have already seen in the previous videos. So वो limit decide करना जिसके beyond, if the values goes on the upper side or goes on the lower side, we are going to reject that product, or we are going to say that this product it does not conforms to the quality, so we are going to reject it. So it is a graph with lines which indicates the tolerances, that is the limits within which variation from the average quality is permitted, any upper level or lower level. We have control limit, we have central line, or mean we can say an average, right? And on the other side we have the lower control limit. So these are the tolerance limits, इनको हम बोलते हैं tolerance limits. So this is what we are expecting. So every product should be on this green line. But since we know that there are variations, there are defects, these are natural variations, these are external or internal variations, these are assignable or chance variations. So because of these variations, ये possible नहीं है कि every product should be on the this green line, central line. There are the upper control limit and lower control limit which are being fixed, जो हम चार्ट के थ्रू अभी एक्सप्लेन करेंगे. फर्स्ट प्रोडक्ट आउटकम, सेकंड प्रोडक्ट आउटकम, थर्ड प्रोडक्ट आउटकम एंड सो ऑन. अगर वी आर इन कंट्रोल स्टेट, वी आर इन आउट ऑफ कंट्रोल स्टेट. सो व्हाट डज दीज ग्रीन डॉट्स आर इंडिकेटिंग? Green dots are indicating that these are chance variation, therefore acceptable. Means deviation और जो भी variation green line से ऊपर है, जैसे हमने एक एग्जांपल कोट करा था 14 kg of cylinder. So if the weight of the cylinder is not 14 kg, somewhere higher than 14 kg or lower than 14 kg, but up to a standard, up to a level that we have defined, so we are going to accept it. जैसे 100 grams का हमने example quote करा था, which we have already discussed in the previous videos, right? So if it is 100 grams का अगर upper control limit और lower control limit 100 grams का है, so what we are going to do is अगर 100 ग्राम ऊपर होगा या 100 ग्राम 14 kg से नीचे होगा, so we are going to accept it, right? So these green dots are indicating that these the products or the LPG cylinder or any finished product is within the control limit. So these are because of the chance variation, therefore we are going to accept the product, right? But this product, it is beyond the lower limit, therefore these are because of the assignable variation, and therefore we are not going to accept it. And as far as chance variation and assignable variations are concerned, please refer to my previous videos जहां हमने चांस वेरिएशन और असाइनेबल वेरिएशन की बात की है. सो दिस इज द सैंपल ऑफ हाउ कंट्रोल चार्ट्स लुक्स लाइक. सो देयर आर few pattern, there are few situation. The first pattern is, this is the process which is under control. Value of every product जो अभी work in progress phase में है, right, it is coming in green, which means it is under the control limit. Lower control limit से ऊपर है और upper control limit से नीचे है, somewhere around the central line. right? So this way we can say the process is under control, क्योंकि कोई भी product की जो value है that is not going beyond the limits. Okay, so in this way we can say the process is under control. So few green dots means the product is within the control limit, or the number is quite high in this case, 1 2 3 4 5 6. So out of 10 products that we have taken in that case, so 6 products are beyond the lower limit, right? Which means that process is out of control. So there are two processes. One is process is under control, right? Everything is okay. Other is process is out of control, which means 60% of the outcome out of the 10 product that we have taken into consideration, 6 products or 6 work in progress goods are beyond the control limit. Therefore, process is out of control. They need to go for the rectification and corrective measures. But there is another situation which talks about that right now product or process is under control because all are in green line. The process is under control, but they are progressing towards out of control state, which means we need to check it. The this values of the product in terms of weight, in terms of height, in terms of anything, जो भी हमारे पैरामीटर्स हैं जिसको हम बेंचमार्क मान रहे हैं क्वालिटी असर्टेन करने के लिए, right now they are in green lines, right now they are in green dot, which means they are process is under control now. But अगर हम trend follow करें, so trend follow करने पे what we are getting, the weight or the height or any quality parameter जिस पर हम quality को check कर रहे हैं, it is be continuously increasing. So at one point of time it will jump out of the upper control limit, यानी beyond control limit चला जाएगा and it will rise to the out of control state. So this is one thing very important that is being depicted by the control charts, that process is now under control, but it is moving or it is progressing towards out of control state. Now, benefits and uses of control charts, it helps to separate out chance variation from assignable variation, and it can be elaborated in the form in this particular chart if we see. So all those products which are green in color, these are because of the chance variation. And all those products which are yellow in color, these are because of the external variation or assignable variation. So it helps to separate out the chance variation from the assignable variations. Second one is detects out of control situation, जो भी हमारा second example था, जहाँ out of control situation that we have seen. So it detects, right? It helps us to find out that we are in out of control situation. We need to go for the corrective measures. And third point talks about gives early warning before crossing the limit. It is just an example that this particular diagram, this particular image is reflecting. Right now the process is under control, but it is progressing towards out of control state, which means it gives an early warning, or it is giving kind of alarm to the department that right now it is okay, but it is going to cross the limits. So please take the necessary actions. Every level of operation, the plotting or the average of the products, their values can be ascertained with the help of these control charts. Helps in reducing the scrap, where we can identify if the process is going or progressing towards out of control state. We need to check, we need to take action. So before it is too late, we can go and rectify the things, so that it does not, or the work in progress does not result into the scrap, right? So these are few of the benefits and uses of the control charts. How we are going to calculate the control charts, it is an important task. It is important how UCL here refers to upper control limit and LCL here refers to lower control limit. So it is important how UCL and LCL is calculated statistically, because it is very important to decide the range. So there are different methods suitable in different condition, and we call them different charts or the different types of control charts. So by this diagram we are going to what type of control charts we are going to study are divided into two categories. One is your variable chart, another is your attribute charts. So for calculating the variable charts, we have R chart, that is range, and X chart. X means mean, central line of tendency, mean. So R and X chart will be included in the variable charts. And as far as attribute charts are concerned, we are going to have P, which means percentage or proportion, and then we have C chart. count chart. Before we should go to R and X chart, P and C chart, let us find out what we mean by variable charts and attributes charts. So control charts for variables, characteristics which can be measured is called variable, right? We can have something like A equal to 22, B equal to something, C equal to anything, right? So A, B, C, these are variables. So when we can assign certain constant value to any of the variable, we'll be referring it to the variable charts. So quality is described quantitatively in terms of dimensions like height, weight, etc. So when we have the quality parameters or quality specifications, which we are going to define in terms of quantitative data, so we are going to use the variable charts, and in this variable charts or in these variable charts we are interested in controlling the mean, that is x, or the range of variation, that is upper control limit and lower control limit, we are going to manage. Control charts for attributes, and here attributes refers to where we have a qualitative data for measuring the quality perspective, quality parameters. So characteristics which cannot be measured, these are known as the attributes. We are not going to measure in terms of height, weight, etc., which cannot be measured. So product can be classified as good or bad, or defective or not defective, because there is no clear-cut definition of what we mean by good, what we mean by bad. So it is a relative measures when the firms will be defining the meaning of good and bad. When the firm have only one option to classify the goods as good or bad, or defective or not defective, then we are going to have attribute charts, and we are interested in controlling the proportion of defective units out of the entire lot. How many defective units are there, or the number of defects in a unit, or in single unit how many defects are there. This is the control charts for attributes. We are going to discuss in detail with what we mean by R chart and X chart, P chart and C chart, the calculation of R and X chart, the calculation of P and C chart in the next video. Right? Thank you everyone.